Hello classmates, I'm going to be talking today about some of the theories of aging, their limitations and critique, as well as sharing my thoughts on how to improve upon them. Wear and tear theory firstly. Your parts, your cells, are constantly breaking down and being replaced through cell division, through apoptosis and other methods of cell death. Sometimes they don't replace themselves quite as well. Sometimes there's just degradation that occurs. This explains age-related diseases such as arthritis, osteoporosis, and other degenerative diseases that occur fairly well. It's a cumulative approach to understanding how the body breaks down. Everything that has happened to us within our lives slowly degrades our bodies and ruins their maintenance. Wear and tear was discussed by Aristotle, and then it was expanded upon and given scientific credibility by Weissman in 1889 when he postulated that your sperm and egg cells are immortal, that they can keep regenerating, and that your somatic or body cells are the ones that slowly lose their abilities to regenerate effectively. Somatic mutation theory. It's a variation of wear and tear in my opinion. It's that your cells are damaged by radiation, which causes mutation in your exposed cell's DNA. Though this theory does have confound from Hiroshima survivors who developed cancers more frequently, as this would predict, but they didn't age quicker. Rather, they aged normally, they just developed more cancers. Error catastrophe theory is the third one we're going to talk about. Much like using future copies that you run off in your Xerox rather than a master copy that gets reused to run off your classroom materials, cells make mistakes over time, and those mistakes compound through DNA error. Sometimes they're destroyed by the body, sometimes they're not, and when they're not, they slowly degrade your body's integrity. This results in an aging through dysfunction in enzyme production according to the text. Accumulative waste theory. Accumulative waste theory describes the buildup of waste and other materials that form in your cells that slow their metabolism down, interfere with their ability to replicate DNA. It also interferes with their ability to repair DNA, and this ability to repair DNA is linked to cell metabolism. Cell metabolism is also linked to lifespan. This sort of DNA damage that's beyond repair is also considered highly in how cancers are formed, that our cells damage themselves over time and more or less destroy themselves and become cancerous malignant cells. This is not always the case. Your cell metabolism is closely linked to your DNA repair capacity. This ability to maintain DNA integrity to avoid further mutation is also linked to lifespan. DNA damage which is too great to be repaired naturally is likely a cause of cancer, according to our textbooks, as well as other age-based diseases. The free radical theory of aging is an interesting one. It's sort of a combination of everything so far. In a paper from Gladyshev in 2014, the free radical theory is described as aging caused by the accumulation of damage in cells afflicted upon reactive oxygen species, such as humans. Some species, such as the naked mole rat, do not experience the same reactive oxygen process that humans do. So this is sort of an interesting area where we have animal biology overlapping into psychology. This concept of free radicals has been very useful in defining the contribution of oxidative damage to cells and to bodies in the aging process. However, since the theory was developed in the 50s, there has been enough time for research to start contradicting it. Starting in the 80s, a large number of studies have been popping up that show that there may or may not be some effect from free radicals. In fact, there are some studies that show free radicals cause better things for our bodies. It's sort of a mixed area where you get different results based on what you want to find. This idea that oxidative damage is what's causing aging has limitations, as it does not accurately define the causal relationships and the inevitability of damage accumulation in our bodies, regardless of how little free radicals we actually accumulate. There's a link that will be down below that will link you to the National Institute of Health page where that study can be found. I would like to thank you for watching, and I would love to know your thoughts on how these theories could actually be unified, because I believe that they are all variations on the same thing, in that our DNA is being damaged through the environment, and each one is sort of taking a different approach to get there. But I look forward to hearing from you in the discussion boards.